Okay, question number 1, we've got an equation to solve. Now, when we're solving equations, I like to put a dotted line where the equals is, and remember that what we do to one side, we have to do to the other. So I'm going to write 5x minus 6, and then on the right, I need to expand this bracket. So I've got 3 lots of x and 3 lots of minus 1. So that is 3x minus 3. Now, when I've got x's on both sides, what I like to do is get rid of the smaller number of x's. So I'm going to take 3x away from both sides, and that is 2x minus 6 equals minus 3. And then I'm going to add 6 to both sides to get rid of that. And that is 2x equals 3, because we're at minus 3 on the number line, we're adding 6, we're going to come up to 3. Now all that's left for me to do is to divide both sides by 2, so x equals 1.5. And that's 3 marks. Okay, question number 2. Hasmeet walks once around a circle with diameter 80 metres. So the diameter, the distance across this circle, is 80. There are 8 points equally spaced on the circumference of the circle. Find the distance Hasmeet walks between one point and the next point. So we know that the distance that she walks is that much. There are 8 sections, so we need to do the diameter multiplied by the pi, because circumference is pi times diameter. So pi times 80. And then we need to divide that into 8 sections. So you can do that without a calculator. That's actually 10 pi. But given that this was a calculator exam, let's put it in our calculator. So 10 times pi is 31.41592. Didn't actually say what to round it to, so let's just put 31.4. And we've put our answer there in a couple of different ways. So we definitely get the marks for that. 4 of the points are moved, as shown in the diagram below. Hasmeet walks once round the circle again. Has the mean distance that Hasmeet walks between one point and the next point changed? So no, it hasn't, because she's still walking in total the same distance, and we're still dividing it by 8. We've still got 8 sections. So no, same total, or same distance around the outside divided by 8. Would give the same answer as above. Okay, question number 5, and we need to rotate the trapezium. So for this, you'd want to put your hand up on the exam and ask for tracing paper. So we're going to rotate it 180 degrees. So you'd put your tracing paper over the top like this. You'd put your pen here and you'd spin it around. So you need to draw around the shape on the tracing paper first. And I like to put a little arrow in it to show what way it's facing at the minute. And then when you spin it, if it's 180 degrees, then that arrow is going to be facing down. So spinning that round, spinning your tracing paper. So that's going to be over here, looking like that. There we go. That is now upside down, 180 degrees around the origin. Then it says translate trapezium T by the vector -1, -3. So with a vector, the top number moves it left and right. The bottom number moves it up and down. Positive is right, negative is left. Positive is up, negative is down. So -3 is going to be a 3 down. And -1 is going to be 1 left. So I need to take this shape, move it 1 to the left and 3 down. Now looking at this coordinate, 1 left and 3 down gets us to here. So then I just want to redraw that shape from there using the same coordinate that I moved as the point of reference. Great. Question number 7. ABCD is a trapezium. Work out the size of angle CDA. So CDA, I'm going to fill in the line of that. So let's draw a line going down here. And we know that that makes a right angle. So I've got a triangle here. Now the angle they've asked me for, CDA, if I go from C to D to A, it's making an angle there. So that's the angle that I'm after. Now what do we know so far? We know that this is 10. And we know that it's 24 all the way along. This bit we can get by looking at this triangle over here and doing Pythagoras. So I'm going to do 7.5 squared, take away 6 squared. And I'm taking away because I've already got the hypotenuse, so I want a shorter side of the triangle. So 7.5 squared, take away 6 squared, and that is 20.25. And if I square root that answer, I'm going to get the length of this bit here. So 20.25 inside the square root, and that is 4.5. So I now know that this bit here is 4.5. And if I do 10 add 4.5, that's 14.5. And if I take that away from 24, I'll get the length of the end bit of the triangle. So 24 take away 14.5 is 9.5. So this bit here is 9.5. Okay, so I've done 24, take away 14.5 to get that answer. Okay, now I know this is 6 because that's the height over here, so that's fine. And now I can look at this triangle here. If we're wanting an angle, in a right angle triangle, it's going to be SOHCAHTOA. So let's label our sides, change colour pen. So this is the opposite over here. This is the adjacent here. And this is the hypotenuse. The opposite is always opposite the angle you're interested in. The adjacent is always next to the angle you're interested in. And the hypotenuse is always over from the right angle. So in this case, we've got the adjacent, that's helpful information, and we've got the opposite, that's also helpful information. I don't know the hypotenuse, and I don't want to know the hypotenuse, so that's no good. So we're going to write, is it SO, is it CA, or is it TOA? And in this case, because we've got the opposite and the adjacent, we're going to be looking at TOA. Cover up the thing you want to know and do the sum that's left behind. So covering up the t, because remember the t represents the angle, it's O divided by A. Whenever you want the angle, you either do sine to the minus 1 or cos to the minus 1 or tan to the minus 1 in this case. And in the bracket goes everything else. So tan to the minus 1, the opposite is on the top of the fraction, so that goes up there. And the adjacent 9.5 is on the bottom. Typing that in my calculator, tan to the minus 1, 6 over 9.5, and that is 32.275. So let's do 32.3 degrees because it says it wants it to 1 decimal place. So there we go, that's that one. Question number 9. Yesterday it took 5 cleaners 4.5 hours to clean all the rooms in a hotel. There are only 3 cleaners to clean all the rooms in the hotel today. Each cleaner is paid £8.20 for each hour or part of an hour that they work. How much will each cleaner be paid today? Okay, so if it took 5 cleaners, let's change back to blue. 5 cleaners, 4.5 hours. Then 1 cleaner, it's not going to take less time, is it? It's going to take more time. And because we've actually divided the number of cleaners by 5, the amount of time it's going to take is timesing by 5, because it's going to take 5 times longer for that one person. So 4.5 multiplied by 5 gives me an answer of 22.5 hours. So it's going to take 22.5 hours if 1 cleaner was doing it on their own. Okay, so then if I've got 3 cleaners, that then takes 3 times less, okay, because you've got 3 times as many people. So I'm going to do 22.5 divided by 3, and that is 7.5 hours. So each cleaner is paid £8.20 for each hour or part of an hour that they work. How much will each cleaner be paid today? Okay, so then we need to take the number of hours that they work and multiply it by that hourly rate. But it says they get £8.20 even if they only work part of the hour. So they're going to get 8 hours worth of pay. So it's going to be 8 hours multiplied by £8.20, and 8 times £8.20 is going to be £65.60. So that's that one. Okay, question number 11. The pie chart gives information about the ages in years of people living in 2 towns, Adley and Bridford. I've got Adley there in that pie chart and Bridford there. The ratio of the number of people living in Adley to the number of people living in Bridford is given by the ratio of the areas of the pie charts. What proportion of the total number of people living in these 2 towns live in Adley and are aged 0 to 19? Okay, very tricky question. And we've not seen this very often, so we're looking at the pie charts to scale, okay? So I actually need to work out the area of the pie charts. Now, measuring this distance, because I want the radius to be able to do it, we can see that the radius of Adley is 5. So the area of this pie chart is pi times 5 squared. With the bottom one, this radius is 4. So to get the area of this circle, it's going to be pi times 4 squared. Okay, so that's 25 pi for this one and 16 pi for this one. Now it says that the angle for 0 to 19 on Adley is 70 degrees. So measuring that with your protractor, you should get that that is 70 degrees. So therefore, it's going to be 70 out of 360 multiplied by 25 pi. So 70 out of 360 multiplied by 25 pi would give you the numerator, and that's going to be out of everyone all together, which we know is 25 pi, add 16 pi, so that's going to be 41 pi. Okay, so that's probably how I would do that question. So I'm going to type in my calculator 70 over 360, because that's what fraction of the pie chart we want, multiplied by 25 pi, and that is 15.271. So that's quite a horrible decimal. And then we're going to divide that, so that is 15.27163.095. And then I'm going to divide that by the total amount, which is 41 pi. That's what it's out of altogether. So divide that by 41 pi, and that is 0.11856. So it's going to be 0.119, correct to 3 significant figures. Okay, quite a tricky one, that one. Question number 13. At the beginning of 2009, Mr. Veal bought a company. The value of the company was £50,000. Each year, the value of the company increased by 2%. Calculate the value of the company at the beginning of 2017. Give your answer correct to the nearest 100. So this is compound interest. We're taking the £50,000 and we're multiplying it by 1.02. I want 100% of the business and an extra 2% on top. So that is 102%. So to get that, we're going to multiply by 1.02. Now we raise that to the power of how many years? So 2010, 2011, 2012, 2013, 14, 15, 16, 17. So that is 8 years of increase. And then we just pop that in our calculator. So I've got 50,000 times 1.02 to the power of 8. And that is 58,582.97. But it says round it to the nearest 100. And that's going to be 58,600. Because I'm looking at the tens, and that is rounding up. Okay, at the beginning of 2009, the value of a different company was 250,000. In 6 years, the value increased to 325,000. So I know it is 250,000 that's been multiplied by something, and we've got £325,000 now as the valuation of the company. This is equivalent to an increase of X% each year. Find the value of X. So if it was a 2% increase, we do 1.02. If it was a 5% increase, we times by 1.05. But no matter what it is, we're raising it to the power of 6, because it's 6 years. So this is something, I'm going to call it Y, to the power of 6. Okay. Now it's not just X, because we're not going to times by, if it's a 2% increase, we're not timesing by 2. So this is something to the power of 6 here. Now I'm going to start by doing 325,000 divided by 250,000 to find out what needs to go here. So 325,000 divided by 250,000 is 13 over 10, so 1.3. So this here needs to be 1.3. So something to the power of 6 equals 1.3. Now to go backwards to work out what that number is, I need to do the 6th root. So on your calculator, if you press shift, there'll be a little yellow symbol somewhere that has any root that you want to put in it, and you can put the root in that you like. And if we put 1.3 inside that 6th root, it gives us 1.04469. Now that would be what percent? Okay, what percent would that be? Now when we had 2%, the multiplier was 1.02. When we had 5%, the multiplier was 1.05. So in this case, it's going to be 4.46%. Now it says give it to 2 significant figures, so I'm going to put 4.5% because the next number is a 6. Tracy's going to choose a main course and a dessert in a cafe. She can choose from 8 main courses and 7 desserts. Tracy says that to work out the number of different ways of choosing a main course and a dessert, you add 8 and 7. Is Tracy correct? You must give a reason for your answer. So when we want to do the number of different combinations, we actually multiply the numbers together. So no, Tracy is not correct. She should have done 8 times 7, and that would be 56. I think there's a typo in the mark scheme because it says 8 times 9, but it definitely should be 8 times 7 that she does. Okay, then 12 teams play in a competition. Each team plays each other team exactly once. Work out the total number of games played. So you've got 12 teams all playing 11 other teams. So we're going to do 12 times 11. But the problem with this is that it tells you that AB is a match, like team A playing team B, but it would also include team B playing team A, which is the same match, right? So we kind of want to discount half of the answers. So we're going to divide this by 2. So 12 times 11 divided by 2 is 66. So for a histogram, we need to divide the frequency by how wide the category is. So because this first category goes from 140 to 150, that's got a width of 10. So 15 divided by 10 is 1.5. And then I've got to do 30 divided by how wide this category is, which is 5. 30 divided by 5 is 6. Then I'm going to do 51 divided by 5, because that next category is 5 wide, and that is 10.2. And then 36 divided by 5, which is 7.2. And then 18 divided by 15, because that's how wide that category is, and that is 1.2. So I'm just looking at how wide each category is. And what that does is it makes sure that the frequency is the area of each of these bars. So the first category is from 140 to 150. I'm just going to go 140, 150, 160, 170, 180 and 190. And then up the side here, we need to make sure we go up to at least 10, because that's going to be that frequency. So let's go 2, 4, 6, 8, 10, 12. So up the side here we call this frequency density, and that's going to be plotting up the side to make sure that the area of the bar is equal to the frequency. So for the first category, 140 to 150, we need to go up to 1.5. I'm going to use my straight line tool here. So 140 to 150, we go up to 1.5, which is about there, and that's going to make sure that that bar has an area of 15. So the area of the bar is equal to the frequency, base times height. So then for the next one, we need to go up to 6, and it's 150 to 155. So notice that this bar is only 5 wide. And then the next one needs to go up to 10.2. So 10.2 is going to be 1 square above 10. I'll do it as accurate as I can on my iPad. And then the next category goes from 160 to 165, and that's going to be 7.2. Just there. And then the last category is 15 wide, and that's going to go up to 1.2. So we're just doing whatever it needs to be to make the area correct. And then it says work out an estimate for the fraction of students who have a height between 150 and 170. So we know that we're looking at the area for this bit, and this bit, and this bit, and this bit, because how many students is given by the area. Now I don't need to work out the areas for the first 3 bars. I know it's going to be it's going to be 30, 51 and 36. So 30, 51 and 36. And then this bit, to get the area, we're just going to do base times height. Now the base has a width of 5 and the height is 1.2. So 5 times 1.2 is 6. So we're going to add 6 on for the area of that bit as well. So the total number of students who have a height between 150 and 170, let's add that together. 30 add 51 add 36 add 6, and that's 123 out of all the students all together. And we're told in the question that's 150. So 123 out of 150. Question number 19. A triangle has vertices P, Q and R. The coordinates of P are -3, -6. So let's give this a rough sketch. -3, -6 is like there. So that's P, -3, -6. The coordinates of Q are 1, 4. So that's like here. Q, 1, 4. And the coordinates of R are 5, -2. So that's like somewhere over here. R, 5, -2. M is the midpoint of PQ. So hang on, let me join them all up. M is the midpoint of PQ, so that's going to be somewhere here. N is the midpoint of QR, so that's going to be somewhere here. Prove that MN is parallel to PR. So MN is this line here, and we want to show that that's parallel. Now, to show that it's parallel, we need to show that the gradients are the same, okay? So first thing we're going to do is find out what these coordinates are. Now, the midpoint, you're going to do x1 add x2, divided by 2, and y1 add y2 divided by 2. So you're like doing the average. So looking at the x coordinate for each of those, -3 add 1 is -2, and we're going to half that, which is -1. So that x coordinate is -1, and then the y coordinates, again I'm going to do -6 add 4, which is -2, and divide it by 2, which is also minus 1. So that coordinate there, m, is minus 1. For n, we're going to do exactly the same thing on this side. I'm going to do this x, add this x, divided by 2. So 1 add 5 is 6, divided by 2 is 3. And then 4 add minus 2 is 2, divided by 2 is 1. So 3, 1. Okay, so now what we're going to do is get the gradient of this line and get the gradient of this line. And doing that is going to be rise divided by run. So what I need to do is work out how much we've gone across and how much we've gone up to get from m to n, and how much we've gone across and how much we've gone up to get from p to r. So for m to n, I've gone from minus 1 to 3. So I've gone across by 4, and I've gone from minus 1 to 1, so I've gone up by 2. So m to n, the gradient is rise over run, which is 2 divided by 4, which is a half. For p to r, I've gone across by, now we're looking from minus 3 to 5, I've gone across by 8, and from minus 6 to minus 2, I've gone up by 4. So 4 over 8 is rise over run for the gradient, and that is also a half. So then we would say same gradient, therefore parallel. Great. Question 21. 12 counters in a bag. There is an equal number of red, blue and yellow counters in the bag. There are no other counters in the bag. 3 counters are taken at random. Work out the probability of taking 3 red. Well, it says there's 12 in the bag and there's an equal number of red, blue and yellow. So if there's an equal number, let's divide that by 3. So there must be 4 red, 4 blue and 4 yellow. That adds up to 12, and there's an equal number of each colour. There's no other counters in the bag. 3 counters are taken at random. What's the probability of taking 3 reds? So the first pick, the chance of taking red the first time, is 4 out of 12, or a third. And then we're going to multiply that by the chance of picking it again, and then multiply that by the chance of picking it a third time. Now, the second time we pick it, we can't pick the same counter again. So there's only 3 red counters left out of 11 counters altogether. And then the third pick, there's only 2 red counters left out of 10 counters altogether. So multiplying that together, 4 times 3 times 2 for the numerator, and 12 times 11 times 10 for the denominator. So 4 times 3 times 2 is 24. And 12 times 11 times 10 is 1,320. That fraction simplifies to be, oh, you don't need to simplify, you can just leave it as it is. That is 1 over 55. So either of those answers is absolutely fine. The 3 counters are put back into the bag. Some more counters are now put into the bag. There is still an equal number of red, blue and yellow counters in the bag. There are no counters of any other colour in the bag. 3 counters are taken at random. Is it now less likely or equally likely or more likely that the 3 counters will be red? You must show how you get your answer. So let's just say that we add 1 counter of each colour. So let's just say instead of having 4 reds and 4, what were the colours, blue and 4 yellow, let's just say that we've now got 5 of each. Then the probability of red is now 5 over 15 times 4 over 14 times 3 over 13. That's the probability of getting a red 3 times now. You could choose any number as long as you've added more and put it in. Let's just see what happens. So 5 over 15 times 4 over 14 times 3 over 13. And that is 2 over 91, which is 0.021978. It's all recurring, but there we go. Whereas up here, 1 over 55, that's a decimal, that was 0.018. So we can see that actually the probability has got bigger. So it's now more likely to get 3 reds. Okay, question 23. S is a geometric sequence. Given that root x minus 1, 1 and root x add 1 are the first 3 terms of S, find the value of x. You must show all your working. So with a geometric sequence, we know that this term has been multiplied by something to get the next term, and then that term is multiplied by something to get the next term. That multiplication has to be the same number. So I know that this multiplied by this has to be equal to this multiplied by this. So I'm going to write that as an equation. Root x add 1 divided by 1 is equal to 1 over root x minus 1. So because they're multiplying by the same amount each time, whatever it is, I know that this term divided by this term equals this term divided by this term, because the multiplier has to be the same. And then I'm just going to multiply that up. So I'm going to times this denominator up here and this denominator up here. And I can do that because the equal sign is in the middle. So I'm going to get root x minus 1 times root x add 1 equals 1. Now root x times root x is just x. Root x times 1 is plus root x, minus 1 times root x is minus root x, so that's gone. And then I've got minus 1 times 1, which is minus 1, and that equals 1. So I'm going to need to add 1 to both sides, so x equals 2, and that all works out very nicely. Show that the fifth term of s is 7 add 5 root 2. So we now know that each time we're going to the next term, it's multiplying by, no it's not. So we now know that the first term is root 2 minus 1. And then we know the next term is 1. And then we know the next term is root 2 add 1. And we're looking for not the fourth term, but the fifth term. So I know that to get from one to the next, I could do this divided by this to find out what we're multiplying by each time. But to be honest, then I'm going to end up with a third on the bottom of the fraction, so I don't really want to do that. I'm actually going to do this one divided by this one, because that's nice and easy. Root 2 add 1 divided by 1 is just root 2 add 1. So we can see that each time the term is being multiplied by root 2 add 1. So times by root 2 add 1. Times by root 2 add 1, and so on. So each time we're going to multiply by root 2 add 1. So first thing I need to do to get the fourth term is do root 2 add 1 times another root 2 add 1, which is 2, add 1 root 2, add another root 2, add 1, which is 3 add 2 root 2. Now to get to the fifth term, I need to take that term and multiply it by root 2 add 1. So 3 times root 2 is 3 root 2. 3 times 1 is 3. And then we've got 2 times another 2 coming from both the root 2's timesing together. So that's going to be add 4. And then root 2 add 1 times 1. So add 2 root 2. So altogether I've got 5 root 2 add 7. And that's exactly what they told me to get. I've done it the other way around, but it doesn't make any difference. 7 add 5 root 2.